All right, we are going to go ahead and look at sine, cosine, and tangent of what are called our quadrantal angles because the terminal ray lies on an axis. And so in order to do this, we're going to look at the unit circle, which is a circle centered on the origin with a radius of 1, and that will help us find these angles. So here it is. Some really important information comes from this, not just for what we're doing now, but for other things. As we look at this, in order to get to our point x, y, we have our angle A here, and we have to go over x and up y. So the point on the actual unit circle is xy, but let's take a look at some trig ratios that we work with here. If we were to find the sine of A, so here's our angle A, the sine of A is opposite, which is y, over hypotenuse, which is 1, and you get sine of A is 1. Cosine of A, that's adjacent over hypotenuse, so x over 1. So the cosine of the angle here in the unit circle is simply equal to the x value. And the tangent of A is opposite over adjacent. It's y over x. So again, this angle A could be anywhere on the unit circle. We just picked a generic one there, but sine of any angle on the unit circle will just be equal to the y value. Cosine will be equal to the x value, and tangent will be equal to y over x. Well, what does that mean for our quadrantal angles? Well, for a 90-degree angle, we know that the sine of that angle will be equal to the y value. So what's the y value? Well, the y value is 1, which means sine of 90 is 1. Nice and easy. Cosine. Cosine is equal to x. So cosine is equal to x. Cosine of 90 is equal to x value, so that's going to equal 0. And tangent of 90 is going to equal y over x. So y over x, which you think 1 over 0, well, that's undefined. So tangent of 90 is undefined. So we'll be able to fill these out in our table once we get back to that. Next, we're going to go ahead and look at a 180-degree angle. So we know that our sine of 180 degrees is going to equal our y value, and cosine is going to equal the x value. So sine is going to be 0, that's the y value. Cosine of 180 is going to be the x value, which is -1. And then tangent is going to be the y value over the x value, or sine over cosine. So that's 0 over -1, which is just 0. Let's go to 270. So a 270-degree angle, once again, we know the sine will equal the y value, sine of 270, cosine will equal the x value, and then tangent will be y over x, or sine over cosine. So sine is -1, cosine of 270 is 0, and tangent of 270 is, actually I should say -1 over 0, which is still undefined. And then lastly, we have actually a 0-degree angle or a 360-degree angle. They're coterminal, so their values are going to be the same. Regardless, sine will be the y value, sine of 0, or sine of 360. The x value will be cosine, so this is cosine of 0 or cosine of 360. And so we have 0, cosine of 360 is 1, and then tangent is 0 over 1, which is 0. And again, I have 360 here, but remember, it's also sine, cosine, and tangent of 0. So from that slide, we can fill in the rest of our chart, the quadrantal angles. Looking at 0 to start with, sine of 0 is 0, cosine of 0 is 1, and tangent of 0 is 0. Then we got down to 90, sine was 1, cosine was 0, the tangent ended up being undefined because 1 divided by 0. Got to 180, it was 0, and then a negative 1, 0. Dropping down to the 270-degree angle, which I should have mentioned before, this also works for all the radian measures, but this is going to be negative 1, 0, and undefined. And as mentioned, 360 and 0 are coterminal angles, so those are going to be the same. So we have 0, 1, 0. And we have completed this chart. We can use this to help us find sine, cosine, and tangent of any of the special angles within the first rotation.